Hey guys, this is Heba again. I'm really excited for today, but because today we're gonna go over some gut health myths or things that people use to improve their gut health, and we want to be able to break it down with research whether this is something that's actually plausible or not. For example, big things that people will eat are like chlorophyll. Some people take like a lot of supplements to improve their gut health, and I think it's important that people know how to break down scientific research so that they can validate whether certain things are actually uh, it actually can help or their stomach or their symptoms or their gut overall, um, and generally their health overall as well. And so today we're actually going to focus on chlorophyll. Now there's been a lot of videos on people using chlorophyll and breaking that down on whether it can actually improve your gut symptoms, it can improve your body or not. And honestly, I don't know. And so like I said, just as I said before, is like this is I would love to explore whether this is the case or not. And so today, that's what we're going to do. Now, before we do that, I think I want to share a couple of disclaimers. One is I'm not a researcher. I'm not a doctor. I'm not a physician, doctor, researcher. And so whatever I say, this is just me and learning from my experience and me sharing that journey with you. Whatever health decisions you make from this, please, please, please consult your physician or healthcare professional that you trust to be able to make that decision. Um, yeah, and besides that, because you want to be able to know the research, but then also be able to kind of have comfortable conversations with your healthcare professional so that you're able to decide whether this is decide with them whether this is any changes in your health. Sorry, if you can make decisions on the different actions you can take with your health, you want to be able to be comfortable talking about that with your physician. There we go. Now, in terms of what paper we're going to go through, it's going to be this paper. It's plant green pigment of chlorophyllin attenuates inflammatory bowel diseases by supplementing autophagy and activation in mice. Now, this is a scientific research article, and sometimes the language can be complex, and I will try to simplify some of the things. And so if I find that I'm missing nitty-gritty details, please forgive me. I also want to make this an opportunity to be this video an easily understandable understandable video for the general audience as well. And so if I miss out on certain key details or nitty-gritty details, feel free to leave them in the comments before, and I'm happy to take that feedback in as well. Alrighty, so let's get back to this paper. Now, chlorophyll. What is it and why do people use it? Chlorophyll is like the stuff that gives plants their green color. And so if you like green vegetables like broccoli, you're already taking chlorophyll because broccoli is green, and that's the chlorophyll is what gives broccoli that green color. But recently, as I mentioned earlier, there has been an increased promotion of chlorophyll on social media as a health supplement. And so I think it's worthwhile to investigate whether it can actually be beneficial. So we're going to look at this paper that investigates whether chlorophyll improves IBD. This study was done in mice with induced IBD, and where they looked at the colon of those without IBD, which is our control, and those with IBD, and also those with IBD and the chlorophyll treatment over a period of days. So there's in summary, there's three categories of mice that they looked at in terms of the treatment assessment as well. So you have your control. This is the mice that don't have IBD, and they look at their colon of that, a colon and other markers within that group. The second group would be those with IBD, and same thing, they will look at the colon and other markers that indicate IBD symptoms within those mice as well. And the last group is those who have inflammatory bowel disease and were also given the chlorophyll treatment over a period of days. And same thing, they will assess their colon, and other markers of inflammatory bowel disease. Now, before we dive into this paper itself, here's some contextual knowledge. Chlorophyll, which I kind of touched on earlier, it's what makes plants green. The inflammatory bowel disease, which is IBD, I'll use those interchangeably. It's not the same as IBS. What IBS is more symptomatic, and you can have symptoms like bloating, gas, etc. Or you can or nausea could be a certain symptoms of IBS as well. But with an IBD, there is a physical manifestation as well, in the sense that an individual who is diagnosed with IBD can also get lesions or mucus along their digestive tract as well. And so some examples of inflammatory bowel disease are Crohn's and colitis. And so that's our second definition, inflammatory bowel disease. And our third definition is autophagy. So autophagy is your body's way of removing dead or damaged cells throughout your body. And so having too high or too little autophagy within your body can indicate there's a potential autoimmune disease where your body may not be isn't able to care for itself as it normally should. And so in this paper, having high autophagy means that you have a higher presence of inflammatory bowel disease. So now let's in terms of let's start with the paper over here. I'm looking through the paper while I'm also talking with you, and I want this to be a very casual setting too. And so what I will say, so we talked about IBD, we talked about chlorophyll. That's kind of what the summary of this paper is going to be, and the big things that I will look at mostly in terms of each figure is body mass, colon length, the histology of cells, which will go over what histology is, and other inflammatory markers that will indicate whether IBD is getting better with chlorophyll in these mice or not. So let's start looking at the results of this study. So we're going to first look at the body mass of all three groups, the control, those with IBD without the treatment, and those with IBD and with the chlorophyll treatment. We're going to look at the body mass of those. And that's shown in figures 1B and 2B as well. And what we see, let's start with 1B here. What we see is that the control a group of mice, they were all given the same diet. By the way, that's important to know. They were all given the same type of diet as well within each groups over the period of days. And so the body mass of the control group, those without the inflammatory bowel disease, stayed consistent mostly, or maybe they increased in body weight. That's what we can see with 1B. But with those with IBD without treatment and those with IBD and with the chlorophyll treatment, we noticed that their body mass significantly decreased, and that towards the 30 to 40 day mark, the control group had a slightly increased weight in comparison of those with IBD and not in comparison of those who have IBD but didn't receive the treatment. And so we see some increase in weight, and those stars that we see indicate that it is a statistically significant difference. And so that's an important consideration to think about, that maybe it helped with increasing having the chlorophyll potentially may have helped increase the body mass of those who have IBD after they had decreased. But it's also important to note that even with the chlorophyll treatment, the body mass is still significantly much less than the control. And so we don't know if that's we can't really determine whether this is a perfect cure or perfect treatment for those individuals with IBD. Now let's look at figure B. Same thing we see here as well. This is 1B, and same thing we see is that the control again stayed consistent or potentially and slightly increase in body mass, and there is a slight, again, same patterns of slight increase of body mass of those with IBD and receiving the treatment, but that disparity that we see between the control and the other two groups is so great. And so this can bring like the results into like, this can bring like having chlorophyll into question whether it is a proper supplement or not. Now, let's look at the colon length. Colon length, how they measured is that they took out the mice's colon of all three groups, a couple of colons from each group, and they measured it and see how they were affected. Now, viewer discretion. If you are kind of squeamish about this, then I would like skip it, and I'll note down where to skip it too. And so when we look at the colon length and the difference, it's noted down in 1C. Let's start with 1C, figure 1C. We notice that the colon length is pretty long, and it's pretty lengthy here in comparison to the other two groups. And this graph over here also kind of, you'll see the graph with the blue, red, and green lines. It also shows that the blue colon length of the control group is pretty high, pretty large as well in comparison to the other two groups. And with the third group, the mice with IBD and were given chlorophyll, we see that there is a slight increase of colon length, but again, this isn't statistically significant. And when things are like statistically significant, actually, I should probably clarify what statistically significant means. Statistically significant, outside of the math of it, it just means that whether this difference is actually significant enough or if it is just like by chance. And we measure it like by the amount of error that's within that the error benchmark that like the analysts like kind of target. And so if the error is like, in this case, it goes beyond the difference is not enough between the two groups to show that there is a statistically significant difference. And so we can't really say that whether this is supported or not with chlorophyll. In terms of 2C, we see that same patterns here where like, yes, the colon of the control group is very high, but then and it's the higher than the other two groups. But here we do see like a statistically significant difference between the group that were given chlorophyll versus those mice with IBD that weren't given chlorophyll treatment. And so this seeing that there is like a slight difference and this is statistically significant compared to the other group says some important things to us as well. But again, what does this show? That this is chlorophyll is a cure? Definitely not. It's just kind of support that maybe it could alleviate something, but we can't really conclude that at the moment because again, we've only looked at two different sets, the body mass and colon length. So we have to investigate a little bit more by looking at the other figures. Let's look at the histology here. And so histology is when they like look at the cells or they kind of like stain parts of the colons and they like assess it. So let's look at our third set of figures, which looks at the histology of the colon. And histology is pretty much looking at tissues and cells under the microscope. And so that's what the figures we look. And so I'll have the figures on the side here as well. And let's start with 1E. Now, with 1E, they look at the different sections and different types of staining within the colon region, and it'll just normally, if you don't have a hard time understanding what part of the body that they're looking at, they will always mention it within like the captions of the figures as well. So in this case, we're looking at figure 1E, and here it's saying that it is like H&E staining for the colon. And so this is looking at the colon. This figure is looking at the colon. And when we look at the histology score, what these we are seeing like that there is so when we're looking at the histology of this colon here, what we see is that look at the linings here. The linings here of the, let's look at colon HE, like this, the top left corner of that figure. We said these are, we look at how this tissue is like shaped and the patterns within it. And when we look at the second group, the mice with um, DSS just means those with IBD. And so when we look at the colon cells of those who have IBD, who are induced IBD, we see that the shape of everything looks very different. And that's very important to note. And then, however, when we give the mice the chlorophyll treatment, we see like there's some of that pattern coming back that was in the original control group, but again, not back to normal onto what that control group originally was, but we see like slight improvements. And that's and then we see like similar things happening as well. These are three different types of staining, and they're assessing like almost the similar things, but the important thing is to look at like the patterning and patterning, and we see the same consistent types of trends here where we have a specific pattern within the control group, but then when you induce IBD within the mice, it kind of destroys that patterning within that colon. And however, when you give the mice the chlorophyll, it it brings it back slightly, but never back to what the control was originally. And so when we look at the histology score, it definitely represents what we're seeing as well. So where the control group had like the lowest number of like has a low histology score, but then those with the mice with IBD have a high histology score, but then when they were given the treatment, that histology score decreases, and it is statistically significant, but it doesn't go back to the point of the control. Okay. And then that same pattern, we see it's that same pattern we see in 2E as well. And so with 2E, they're looking same thing, like we start with the same patterning of the colon here, and then with IBD that patterning kind of goes away and looks very disordered. And but when you provide the chlorophyll treatment, it kind of returns to shape, back to shape slightly as well. And so it's very interesting to see. It's actually very interesting to see, I think, how chlorophyll was able to like improve that a little bit, but again, it doesn't bring it back to normal of what that control originally was. Okay, and then okay, let's look at what other. Okay, now let's look at the second set of histology scores that we have, which is they're looking at lymphocytes. Now, lymphocytes are a type of cell that indicate that there's an infection happening. And if you have too many lymphocytes in the cells, that shows, again, there's an infection going on. So, in figure 1G, we see that in the control, we don't see a lot of lymphocytes appearing. But when the mice are induced with IBD, you see all those dots and the yellowing and the browning staining. That's all the indication of lymphocytes. That means there's a high level of infection that's happening as well. Now, when we provide the chlorophyll treatment, those lymphocytes and that gray, then that brownish staining decreases slightly as well. And that's very interesting to see. The fact that lymphocytes were decreased after giving the mice who have IBD chlorophyll treatment. I think that's a very interesting figure to see as well, that like you see less infection, but again, there is still an infection present. Again, and like I said again, we're not concluding whether chlorophyll is the right treatment. talk to your healthcare professional. But we are saying that these are interesting results to see. And yeah, but like I'm curious to see what other results this the study has, and excited to explore that with you. So let's look at figure 3A. Now, what this is another set of figures that's looking at like different types of markers within the cells, and we see like a very distinctive pattern of those mice who don't have IBD, and there's like a very clear patterning that's happening. And then as soon as these mice were uh, IBD induced in them, you see these like lymphocytes and signs of infection happening, and like disorder of the patterning. And then but then we give the chlorophyll treatment, same thing, the patterning starts to come back, we see a decrease of that infection, but again never back to that controlled situation. And we kind of see these graphs are great because it like quantifies it all as well. And so when we look at the control, when we look at the differences between these three groups, we notice that there is a statistically significant difference between each of them. Over here, so between the control and the mice with IBD, there is a statistical significant difference, and between the mice with IBD and those with IBD and treatment, there's a statistical significance as well, different as well. But within like the different sets here, the dependent on the condition, you can see a very significant difference, and areas where like you don't really see it that much, such as in this case over here. And yeah, 3C kind of shows the same patterns we've seen consistently as well. You have that pattern, but that pattern goes away when the mice have IBD, and then but we give treatment, that pattern comes back, and we see less of signs of infection here too. Now, let's look at inflammatory markers. Inflammatory markers. So, inflammatory markers are just like indicators within the body that show that we have that there's an infection happening. And two of the markers that they looked at here was the IL-1 beta and the TNF alpha markers. And we see that within the cells, the control groups had lower levels of inflammatory markers, and within the mice with IBD, there was a higher level of those inflammatory markers. But when you gave them the control group, that levels of inflammatory markers decreased. But in both cases, both for the IL-1 beta and TNF alpha, we don't see a statistically significant decrease of those inflammatory marker levels. We see that there is a difference, but we can't conclude that there was like a statistically significant difference. And that, I think, is an important note to make as well, that even though visually in the histology analysis we saw that there were differences, but that may not necessarily translate into like seeing lower levels of inflammation and inflammatory markers within the body just because you take chlorophyll. Now, we went through half the amount of figures, which is figures 1, figures 2, and figures 3, and each of them had like letters A to like F for some of them for each figure 1, 2, and 3. That's a lot that we went through. Now, there's 3 more sets of figures with 4, 5, and 6, but I'm going to be touching mostly on 4 because they're more like visually they're easier to understand than figures 5 and 6. Figures 5 and 6 and even part of figure 4 focus more on like Western blots and stuff. And I feel like that can be a little bit more complicated to be able to discuss that right now. If anything, I would try to see if I can make like a video that talks about how Western blot what a Western blot is and how to assess them. But that's why for today we're just going to be focusing mostly on figure 4. And so what I have my notes here, so if you're wondering what I'm looking at down here, it's my notes. So when we're looking at figure 4, what they did in this, which I thought was really interesting, was that they blocked autophagy, they inhibited autophagy with this compound called chloroquine, and then they wanted to see what would happen if we inhibited autophagy within mice who have IBD. And so when we look at, so when we look, the two figures in figure 4 that we're going to look at are figures 4b and 4c. Now figure 4b, there's a lot of like colons to look at here, but to summarize, they looked at the colons of mice of our control group, those who didn't have IBD, and then you have colons of the mice that did have IBD here. And then the next group is mice who had IBD and had induced IBD, but then they also gave them the chlorophyll treatment. That's the third group. So that's our typical 3 groups. But then they added 2 more groups here. One is mice who had induced IBD and gave them chloroquine, and the chloroquine would inhibit IBD. It would inhibit autophagy within the mice. And then this last group is mice who didn't have IBD, but they were given chloroquine. And so now that I've explained that, we notice that the mice who had the control group had the longest of the mice that had the control. Let me back up here. The mice of the control group and the mice that didn't have IBD but were given chloroquinone only, those had the highest length of colons. What's also interesting is that the mice with the only IBD without treatment had the lowest length of colon, the shortest length of colons, and we've kind of expected that based on other results. Now, what was interesting piece here was that the mice that were given chloroquine, where they inhibited just the autophagy, they had a slight increased length of their colon. And that's the same thing also of the mice with IBD, but then were given the chlorophyll treatment. And so seeing that there is like a slight statistically significant increase in colon length by giving the mice with IBD either chlorophyll or chloroquine is very interesting. And so that was I'm very interested to learn more about this result and explore more on this, and hopefully I will see more of that later in other studies too. And then the best way to describe gut permeability would be thinking about how easily does our gut lining let things into our gut, and how easily does it let things out of our gut and into the bloodstream or the rest of the body. And I think one phrase that kind of gets tossed around is like leaky gut. Like, I guess, how leaky is your gut? And so that's one way to think about gut permeability. And for C, what shows is that the mice that had only IBD without the treatment had the highest level of gut permeability. And then it was the highest. Yeah, it was very cool to see that it was the highest one. What's interesting to also see is that the mice who had IBD and were given either chlorophyll or chloroquine had much lower gut permeability than the mice with IBD. And so, and the groups between and then the measurement between the mice with IBD and the mice with IBD plus the chlorophyll treatment, that was a statistically significant difference as well. So very interesting to see as well, see here. And honestly, the fact that like chlorophyll did show like a statistically significant difference in like your gut permeability. I never even thought about that, but very cool to see, I think. And so the last bit of this paper is just looking at Western blots and other types of analysis of different pathways and how like chlorophyll does affect the gut health as well. But that they're just a little bit more complex for me to even be explain it, but I would love to make another video to be able to explain how, as I mentioned earlier, and how like Western blots are and how to describe different pathways within our body as well as cellular pathways within our body. And so, and if I have that type of background information available, it might make it easier for me for you guys to be able to understand what's going on within block these figures too. And so, but that does bring up the question though, after looking all these figures, um what can we conclude from this paper? um in the paper, what we can there's a couple things that we can conclude. One is that we can see that the chlorophyll can play a role, but it's definitely not a cure. And we saw this play out several times where yes, providing chlorophyll to the mice did reduce some types of symptoms or inflammatory markers, but it never got back to the level of the control groups of the never ever got to, which means it never got back to the level of the mice who didn't have IBD initially. And so it can play a role, but definitely not a cure. And it that's why I think this is such an important study, because it shows that even if we see at times a statistically significant difference, this one study does not confirm that um does not like 100% confirm that CHL is like a good treatment for those individual with IBD. It definitely can support that type of theory, but in the end, it shows that we need to be able to have replications of studies like these, or having more studies of like these, testing chlorophyll in different types of conditions and different types of environments, so that we can consistently see that whether chlorophyll is going to improve symptoms or not. If anything, like, I think it's a great study, but in order for me to be able to solidly confirm whether CHL is a good supplement to take, I would want to see other studies as well. And that's maybe a homework for you guys to think about as well. What other peer-reviewed studies can you find that look at chlorophyll as um a as a good supplement for managing symptoms? It's very interesting. I would be very interested to see it as well. And the last thing I want to say is that this paper, especially in the discussion, also states that instead of taking chlorophyll directly, you can just eat more green vegetables too. And because green vegetables, what gives them the color is the chlorophyll. I However, I can also empathize with the fact that green vegetables like broccoli um can be very tough on the gut, especially for those who may have IBD or even IBS, and it can be like a tough thing to digest for them. And so I can empathize with that as well. And that is where talking to your family physician or trusted healthcare professional is very helpful, so that you're able to have these open conversations and discuss what your options are, so you're able to have a balanced diet. Which I will reiterate, whatever actions you do decide to take as a result of this video, please consult a healthcare professional and a trusted healthcare professional as well. I beg y'all. And with that, thank you so much for going through this paper with me. I hope I know it wasn't perfect. Like, I know for a fact it wasn't perfect, and there's a lot of things that I could improve on for next video, and I will do my best to do so. But I hope it helped you understand a little bit on how to like read through figures and be able to assess whether this whether to assess on whether certain supplements uh, uh And with that, I will say thank you so much for taking the time to watch this video and go through the study with me. I know it was a lot and it was very complex, and I know my explanations weren't perfect, but I hope I can improve on that the more I do it with you all and the more I explore with you all on different types of supplements and how they can affect the body. I will hopefully try to do more studies, hopefully I will look at hopefully going through more studies with you all, trying to see what other supplements we can look at and how they can affect symptoms, and seeing what those studies have tested on as well. But I hope that this gives you guys a confidence to be able to, look up your own studies, try to see how you can assess them, and then also having open conversations about these with like your healthcare professionals or your friends and loved ones as well who may be looking at this. But like I said, yeah. But with that, thank you so much again for listening, and I'll see you guys next time. Bye.